that in 10.3, we're looking at simplifying radicals. And the biggest thing they're looking at in 10.3 is not perfect square root. Well, some parts of them are perfect square root numbers. Some of them it's more than likely than not doing anything else. So, starting you off with something like this. Let's say you had square root of 400. All right, here's one where, again, it's almost like you can use your calculator. If you check square root of 400 on your calculator, it comes out to a nice even 20. Okay. Now, that's not the kind of problems they're going to... Now, that's obviously not what they're going to throw at you. They're going to give you problems where they're going to change that number by just one little bit. They could make it a little bit smaller, a little bit bigger. I mean, we can even just drop the 0 off. Let's say we're doing the square root of 40. That's what they're going to ask you to simplify. And here's where you're going to have to go back to your 6th grade math class. That what you're going to have to do is, you're going to have to take this number that you have on the inside, the square root of 40, and take the 40 and start breaking it down. So you got it in factored form. And there's two ways you can do it. You can do it with the old factor trees that we did way back when. Start taking the 40, breaking it down. And I always tell people when you're doing these, start with your smallest numbers. I mean, obviously you could do 10 times 4 and 8 times 5 and all these other numbers. But if you're not very good at it, start with something small like 2. Make it 2 times 20. Take the 20, rewrite it as 2 times 10. Take the 10, rewrite it as 2 times 5. So if we took 40 and had it rewritten so we were in prime numbers, we've got a 2, 2, 2, and a 5. And here's basically what we're going to do when we're rewriting these. I want to ask you to simplify. You're going to rewrite the radical expression they give to you, whatever the number it may be. You're going to rewrite it in prime number form. And when you're talking about prime numbers, your big 3 prime numbers are going to be 2, 3, 5. 7's the next one on the list that's used a good bit, but not near as much as 2's, 3's, and 5's, because that's going to get you through most every other problem. Now, you get the other prime numbers, where you have 11, you have 13, you have 19, 17, and 23, all those other numbers, but in most of the cases, those numbers are going to come from doing 2 times 23 or doing 3 times 19 or something like that. So your big 4 numbers, really what it comes down to is 2, 3, 5, and 7. All the other prime numbers just kind of happen when you take out the 2's, the 3's, and the 5's, and the 7's. Okay, so if we take the 40 and break it down, we've got 2, 2, 2, 2, and 5. So if you just rewrite it in factored form, so you've got 2 times 2 times 2 times 5. For square roots. Okay, and based on whatever the root is that you have out here, again, if there's no root, it's understood to be root 2. That tells you how many groups of things you're looking for. So for this one, we're looking for groups of 2 of a kind, basically. If you have 2 of the same number, then you could think about using your square roots. So if you did 2 times 2, that would be 4. What's the square root of 4? Just 2, right? So for that particular one, it's like an exit buddy. If there's 2 of a kind, they have an exit buddy, they get to get out. Where you've got this 2 and this 5 left over, they don't have anything in common. So they have to stay on the inside. And whatever you have on the inside, just going to multiply those together. So if they ask you to simplify a problem, where we're doing square root of 40, again, you would break that down just as much as you possibly can using the prime numbers. And then anything that occurs in groups, you take out anything that's there. It's an exit buddy system. 1 of a kind, you don't get out. 2 of a kind, they get out. You get to go free. Kind of like Finding Nemo, when, Crush asked them, they're getting off the EAC, and do you have your exit buddy? Same thing here. You got to get your exit buddy. All right, let's give you a little bit bigger number here. So let's do square root of 80. Okay, now for 80, we're going to do it both ways. But let me show you a different way that you could do this besides doing the factor trees, because that's usually the one that most people remember going back to middle school and 6th grade and 7th grade, 8th grade. That you had your factor tree, you break it down and go that route with it. As long as you stick with the small numbers first, it kind of works its way out, but here's kind of a different way of looking at it. It's the same thing, but just a different way of kind of doing it. This is what it's the stack or the ladder method. That you almost go back and make a ladder. Now the thing is, instead of making all these rungs to start with, basically just do it one rung at a time, and you really only need half of it. So you can kind of go, and we'll go back and put these in, so you don't have to erase these. But basically go back and set it up where you're going to divide it out this way. We've got a ladder underneath it. The one thing that you have to do, though, is that on the outside here, we're going to put only prime numbers. And it's still kind of the same thing. If you think about 80, think of 2s, 3s, and 5s. What could you divide into 80? Well, it's even, so let's divide it by 2. So if you take 80 divided by 2, that's going to leave you with 40. So there's your first step on your rung of your ladder. 40 still even, divided by 2. Take 40 divided by 2, that would make it out to be 20. 20 is still even, so divided by 2 again. 20 divided by 2 is 10. 10 is still even. Divided by another 2. 10 divided by 2 is 5. And once this bottom number is a prime number, you've gone as far as you can go. And the reason why they call it the stack method or the ladder method is that when you get done, all your prime numbers are stacked up, and they're not spread out all over the place like they are if you do the tree method. Because I was the world's worst when I was doing this one. I would start off with, if this was 400 or 410 or something, I would start off with 40 times 10, and then somewhere in the middle I'd have it all factored out the way I did it, but there'd be a 2 somewhere in the middle that I'd forget about. So I'd have it worked out well, but I'd forget one little number to pull in. If you do the stack method, all your numbers are stacked up, and everything's good. As long as you only put the prime numbers out here. So 80 would be 2 times 2 times 2 times 2 times 5. So there's one pair of 2s, so that 2 gets out. There's another pair of 2s, so that 2 gets out. The 5 is stuck on the inside by itself, so it's going nowhere. And because it's still multiplication, if you pull numbers out, you're going to multiply those two numbers together. So 2 times 2 would make that 4, square root of 5. Now, if you're breaking these down by hand, I don't care if you do stack method or if you do the old factor tree. As long as you can break it down and get the answer you're looking for, either way you go, it doesn't really matter. Okay, let's give you a couple more here. Because they will throw a few big numbers at you when we're going through these. So let's do square root of 360. Okay, now honestly, on these, first thing I would do, if you're not sure about some of the bigger numbers, check it with your calculator, because they'll sneak in some perfect square root answers. So if you check square root of 360, see what it is. If you do the square root of it, you should get some decimal number. Comes up to be like 18.97. So if you get decimal numbers, you know it's not a perfect square root, which means if it's not a perfect square root, you got to start breaking it down. Okay, now here's where if you can kind of see some numbers that pop out at you. If you can see this, it's great. If it's not, you just keep breaking it down. If you want to go with the stack method or the ladder method, you took 360 and divided by 2 because it's even. That would get you 180. 180 is even, so you can divide it by 2. That'd make it 90. Take 90 divided by 2, get 45. Now it's odd, so we got to go with something else. What do you do? 3 times 15 or 5 times 9, it doesn't really matter if you just want to stay with the small numbers and go with 3. 3 going to 45 15 times. Take 15 divided by 3 to get you 5. And 5 is a prime number, so that would be your breakdown in prime numbers. So it's 2 times 2 times 2 times 3 times 3 times 5. And you're looking for the pairs. So there's a pair of 2's, so that 2 is out. There's a pair of 3's, so that 3 is out. And then the 2 and the 5 didn't have another set of pairs, so they'll stay on the inside. So on the inside, you've got 2 times 5 for square root of 10. On the outside, you've got 2 times 3 for 6. Now, here's the other thing you can do, and part of it just depends on if the numbers pop out at you. Hey, sometimes it's, if the numbers pop out at you or not, but it's almost one of those things. That if you're working through some of these numbers, if you see a perfect square root number you could take out of this one and rewrite it that way, that you could take 360. If anybody's thinking, well, that would be 36 times 10, right? Because you've got the 10 on the end of it. Square root of 36 is a perfect square root number, right? So this is where you could separate this into 2 numbers and make it 36 times 10, and then take the square root of 36 and make it 6. So you get the same answer, just get there a lot faster. So if sometimes those numbers pop out at you, that you can see a perfect square root number that you can multiply or divide out of it, however you want to look at it there, then you can go ahead and pull that number out and maybe get to the answer a little bit faster than if you would if you'd taken it and broken it down so it was all in prime numbers of 2's, 3's, and 5's. Okay, now, the couple of times that they'll ask you some of these and where they might give you some perfect square root numbers. Is they may give you something like this, where we've got it in fraction form. So maybe it's the square root of, or the negative square root of 25 over 144. That for one like this, again, if you've got the square root of 25, you can almost separate it in 2 parts. If you have the square root of negative square root of 25 over 144, this is one of those problems where you could almost separate it into parts. That you can do the square root of 25 and make it 5. You can do the square root of 144 and make it 12. And for that one, since the negative was out front, the negative just stays out front. So that's one where they'll give you some perfect square roots, where most of the time you don't get those. But they're going to make you break it up into fraction form to kind of look at the 2 parts of it there. Okay, so on all these, they're just getting you to think about, the options you can do. Sometimes you'll have some perfect square roots, sometimes you have some that's not perfect square roots. And they're using these first few problems to build you up to numbers that are bigger than just square roots. That they're going to ask you to simplify. Now that's all the directions that they're going to have, but in this case they're going to throw some variables at you. And for this part of it, what they're going to have you do is almost go back and rewrite it like we were doing earlier. So they may give you something like this, where you're going to do the square root of x to the fourth. So probably the first thing that they're really going to ask you to do, and again, they don't mention this in the directions, but it's almost, again, one of those where you want to rewrite it. And it's almost one of those things, if they give it to you in square root form or radical form, you almost have to rewrite it in exponential form. So if they give it to you, we're going to say rewrite it in the opposite form. Now, sometimes they may just sneak one in where you can just do it just like it is, but most of the time, whichever form they give it to you, you've almost got to rewrite it in the other form to be able to simplify. So if you have square root of x to the fourth, we're going to take x to the fourth, and because this one is a square root, and divide it by 2. And then you've got this fraction, so what's 4 divided by 2? Easy, right? That's just 2. So there you go. That would be x squared. Okay, and I think that's kind of what we were doing back in section 2, kind of walking through some of those. And then what they're going to do is they're slowly going to kind of mix the two together, where that we've got the variables you can work with, you've got the numbers you can work with, and then they're going to start kind of putting the two together, where that maybe we have something like this, where you're going to do the square root of 27 v to the 8th power. And for me, the easiest way to think about it, if you have 27 times v to the 8th, is to go ahead and separate those two. Just do square root of the number, and then turn around and then do the square root of the variable. When you have a number, which they're going to call the coefficient. Times a variable, that's when you separate those two into parts, two separate parts. And once you've got it separated into two different radicals, well, then you can just do it as two separate problems. We're going to do the square root of 27, just that number, and then we'll turn around and do the square root of v to the 8th. Because the square root of 27, if you start breaking it down, it's 9 times 3. But what's the square root of 9? Square root of 9 would be 3, so that's going to leave us with 3 square root of 3. Okay, and then with the variable part, well, that one you almost have to rewrite it because it's technically the square root of v to the 8th. So that's the one you could rewrite it as v to the 8 divided by 2. So it would be v to the 4th. And everything that you take out of the square roots goes together. So the 3 that we've got here and the v to the 4th would go together. And then the square root of 3 that's left over, well, it stays on the inside by itself. To get your answer, that would be 3 times v to the 4th times the square root of 3. Okay, so they'll give you a few of those where you're going to have some square roots to break down, have some variables that you'll simplify down to these. And then about halfway through section 3, they're going to give you something that's kind of new that we haven't looked at so far. So here's where they're going to kind of break the topic just a little bit. They're going to give you square root of x to the 7th. Because everything in section 2, when we walk through the first part of section 3, if you were to rewrite this one, that would be x to the 7 divided by 2. Now, everything so far when we did this, it worked out even. We had 8 divided by 2, we had 9 divided by 3, whatever the number was going to be with the variables. But in this case, you get 7 over 2. They don't want you to put 3.5 on this one, because that's not what they're looking for. Here's what they're going to ask you to do. Now, we'll take it back to like the long way of doing this, then we'll come back and show you a better way to think about it. If we went back to, again, 6th grade math, if you've got x to the 7th, that would be 7 x's on the inside. 1, 2, 3, 4, 5, 6, 7. And again, because it's a square root with the understood 2 there, we're doing everything in groups of 2. So there's 1x that we can take out. There's another x that we can take out. And there's another x you can take out. And then at the end, we've got this 1x that was inside the square root by itself. So we've got x times x times x. So that would make it x to the 3rd with 1x left on the inside. Okay, now here's what it comes down to when they ask you to do something like this. That instead of taking these and writing it out where you've got all these x's written out or whatever the variable is they give to you, and go back and put it in groups of 2, or if that was a 3, you do everything in groups of 3. Instead of doing all that, here's basically what you're going to do. That if you've got 7 divided by 2, actually go ahead and just divide that fraction. So take the 2, divide it into 7. Alright, so 2 will go into 7 3 times. 3 times 2 is 6. Take away the 1, or subtract the 6, we've got 1 left over. And basically, here's what it is. Once you've divided this thing, ever how many times this thing will go, in this case 3, this is going to be your outside power. Whatever you have remainder, that's going to be the number of variables you have left over on the inside. So that's going to be your power that's going to be left over on the inside of the radical. And so back up here, that's where we've technically got x to the first power. So instead of writing it out where you got all these x's, because if you've got just a handful, 4 or 5, it's not a big deal. When they start giving you x to the 20th power and x to the 30th power, you don't want to write 20 and 30 x's on the inside. So the shortcut way is just take whatever power you have here, set it up like a fraction, and then actually divide that number. And again, every how many times they go into it, that's what power is going to go on the outside. Whatever you have left over, that's how much power-wise you have left over on the inside. Because I think everything so far we've looked at square roots. Well, let's give you one here where it's not just square roots. Give you one that's something different. Let's do x to the, well, hang on. Went too fast here. Got ahead of myself. Let's do the 3rd root of x to the 17th. Because they're probably going to start you off in radical form. All right, again, in most cases, whatever form they give to you, if they ask you to simplify it, you usually are going to have to rewrite it in the other form. So this would be x to the 17 divided by 3. So again, we don't have to write 17 x's because we'll be here a while doing that. So all we're going to do is we're going to take 3 and divide it into 17. That goes 5 times. We have 2 left over. So that 5, again, is your outside power. And then the 2, that's your remainder, that's going to be your inside power. And when we're talking inside and outside, we're talking about inside the square root or outside the square root. So for this one, we're going to have x to the 5th power on the outside. On the inside, you're going to have x squared. The only thing we have to do in this case is because of that 3 that's here, just make sure you put that 3 in for the root there. Now, if you have more than one variable, basically you just have to do it one variable at a time. So let's do the square root of a squared b to the 9th and c. And for me, if they give you more than one power or more than one variable when you're going through these, again, I would break it up just one variable at a time. So you've got the square root of a squared, you've got the square root of b to the 9th, and then you've got the square root of c. And just realize that all those things are multiplied together. And then once you think about them as being separate, and then you may not really need this first step, but basically then you're going to go back and divide everything. So this is a to the 2 divided by 2. This is b to the 9 divided by 2. And you've got c to the 1/2. So you may not need the first step, but again, just thinking of what we're doing here, that we're breaking up into 3 parts. And then from there, just take it one piece at a time. You've got 2 divided by 2, so that's a to the 1st. With the b, again, we want to divide it, so we've got 2 divided into 9. That'll go 4 times with 1 left over. And with the c, in that case, you've got a 1/2. There's really nothing you can do with a 1/2 because it's in simple. Now, think about it when you're dividing this one. You could think about it that way, that you're still going to take and divide 1 into 2. And you could even think that same thing with the first one back here, where we've got a to the 1st. You can still think about it as 2 divided into 2. It goes 1 time with no leftovers. Now, here's kind of the benefit of doing that. If you actually, and I know it's kind of easier to say, why would we divide 2 divided by 2? If you do this, 1 divided by 2 won't go, right? So 0 times 1 is 0. Wait, sorry, got that one backwards. It's supposed to be 2 divided by 1. Two won't go into the 1. So if we take that, we got the 0. 0 times 2 is still 0. 1 minus 0. Of course, you got the 1 left over because it's not big enough. It's as far as it'll go. Here's the benefit of kind of doing it this way. And you may be going, well, okay, with this one, why are we doing all this? Every single number that you do on the top part tells you all the different variables. So these are all your variable powers that's on the outside. And every single remainder tells you what the variable power is going to be on the inside. So for the A's, we're going to have 1 on the outside, none on the inside. For the B's, you're going to have 4 on the outside, 1 on the inside. And for the C's, you're going to have none on the outside, and then you're going to have 1 on the inside. So if you can think about stacking those up and just doing it as one separate problem and actually dividing the numbers out. And again, I know if you've got 2 divided by 2, that'll go 1 time. So sometimes you get numbers like that, but it's easy to look at it. So for this one, for the A, again, we're going to have 1 on the outside. For the B's, we're going to have 4 on the outside. And for the C's, we've got none on the outside. For the A's, none on the inside. We've got 1 B on the inside. And we've also got 1 C on the inside. So we didn't need that record to be that long. And that would be the answer that you're looking for. All right, let's do that one again with a little bit bigger numbers here. Let's go third root. Sometimes if you go third root, it makes it a little bit more difficult. Let's go with third root of x to the 10th, y to the 25th, and c to the 18th. So we've got x to the, and again, if you think about breaking them up in separate parts, that we've got x to the 10 thirds, you've got y to the 25 thirds, and you've got z to the 18 thirds. Okay, and again, numbers that you can do, now we've got 18 divided by 3, we know that would be 6, but again, just to kind of keep a habit, keep something going here, let's take each one of the fractions and actually divide it out. So we're doing 3 divided into 10. 3 going to 10 3 times with 1 left over. Same thing with y. We'll take 3 and divide it into 25. 3 going to 25 8 times with 1 left over. And with the z's, take 3 and divide it into 18. So 6 times with no leftovers. Again, it seems like some of the problem, especially with the z with 18 divided by 3, we know it's 6. But for the other ones, it helps just kind of keep a pattern going if you do the same thing. That all the top numbers, again, these are all the powers that's going to go outside. And every single thing on the bottom, those are going to be the inside powers. So when we put it all together, we're going to have x to the third on the outside. We're going to have y to the 8th on the outside. And z to the 6th on the outside. On the inside, we're going to have 1x. And we're going to have 1y. And the only thing you have to be a little bit careful of, sometimes when you're going through these, the one thing that's easy to kind of forget is that it was to the third root back up here. So make sure in your answer you go back and put that as the third root. That's the one thing that kind of slips by you that you forget about, because you get so used to dividing everything out and getting the powers inside out that you forget that it was the third root, not a square root. Okay. And then same thing we had with the other problems is that once you've gotten used to just doing one variable, then the next thing they're going to do is they're going to walk you from having just the variable to giving you the numbers in front, giving you a coefficient, and have you break down the numbers at the same time. So we'll do square root of 28 u to the 5th and t to the 17th. Okay, so for this one, again, this is one of those where you might actually want to break up in all 3 parts before you start to break it down. That you've got the square root of 28, you've got the square root of u to the 5th, and then you've got the square root of t to the 17th. And this is one, variable-wise, it's probably going to be easier to do the variables because it's just u and it's 5 divided by 2. And then for the t, 17 divided by 2. The square root of 28, that's the one you actually have to go back and start breaking it down. Whether you do the stack method or whether you do the factor tree, that's where you want to break it down and do what you can do. And again, perfect square root number-wise. Hopefully, maybe you can see that that's 4 times 7. And if you do the square root of 4 times 7, square root of 4 would be 2, and then you've got square root of 7. Okay, and then the rest of it, you're going to have to break it down like we were doing a minute ago. For the u, you're going to take 2, divide it in 5. 2 will go into 5 2 times. 2 times 2 is 4. 1 left over here. And for the t's, same thing. We'll take 2 and divide it into 17. So I'm going to go 8 times with 1 left over. Again, the top numbers, your whole numbers, basically are your outside powers, your remainders, your leftovers. That's your inside powers. So on the outside, and we can kind of look at 2 different parts here. You've got the 2 from this one that's here. You've got a u to the 2nd power that's on the outside. You've got a t to the 8th power. And on the inside, we have the 7 that was here. We're going to have 1 u and 1 t. So, and they'll just keep giving you those to keep practicing over and over, just working through the parts and just breaking them down until you've had, an assortment of all kinds of different variables, different numbers, and just doing different little pieces of it there. The one good thing is they tell you that all the answers, all the variables are positive, so we don't have to worry about any pluses or minuses with the square root. Just take the number as it is and then break it down from there. All right, now one thing we didn't do. We pretty much stayed at second root with the variables. We've stayed kind of third root. We could throw some other things out there. The one thing we haven't really done a lot of is working with some of just the coefficients where we bump it up to fourth roots. Let's take a little bit bigger numbers where we're going to do the fourth root of 96. Okay, and again, depending on how you want to break it down, if we take 96 and start to break it down, for this one I'll go with a stack method here. 96 is even, so that's 2 times, or take 96 divided by 2 to get 48. 48's even, so we can divide it by 2. To get 24, 24 is even, so divide it by 2. To get 12, 12 is even, keep dividing it by 2, so we get 6. 6 is even, divided by 2, and we get 3. And finally at the end here we get a lot of 2's, we get a 3 at the end, so we've got our number broken down in prime numbers. Okay, and then bring it all back together. 1, 2, 3, 4, 5 2's. And then 3. Okay, and for this one, you're looking for 4 of this kind. There's 1, 2, 3, 4 2's that we can circle. So that 2 would come out. And again, everything else just has to be in groups of 4. Well, we've only got 1, 2, and 1, 3 left over. So those would stay on the inside. Again, whatever you've got left over, just go back and multiply those numbers together. So we've got 2 times 4th root of 6. So when they bump the power up beyond 2's, which we looked at just almost everything square root, they'll bump it up into third roots and fourth roots. That just means you're looking for groups of 3 if it's third root, or groups of 4 if it's fourth root. They shouldn't really go beyond third or fourth root, because after third or fourth root, it's just the same concept, just bigger exponents and bigger numbers. Okay, and let's see, let's give you maybe one more example that we got here. And for this one, we'll go with a third root, because we didn't do a whole lot of third roots. So third root of 135. Let's go with k to the 13th and p to the 6th. All right, the first thing I would think about is, again, just think about doing it in 3 separate parts. That you've got the third root of 135. You've got the third root of k to the 13th, and we've got the third root of p to the 6th. Okay, so then just take it, start breaking it down with the numbers. And again, with 135, think about all the numbers you can do to break 135 down. First thing I'm thinking is it's odd, so 2's are out, so you go with the 3's. Well, you know it ends in the 5s, so you might even just go ahead and divide it by 5. Take 135 and divide it by 5. That should go 27 times. 27, you can divide it by 3 to get 9. 9, you can divide it by 3 to get 3 times 3. So prime numbers, we've got 3, 3, 3, and then the 5. So if we're doing third roots, we're taking this group of 3 out, and that 1, 5 is left over on the inside. Okay, and then variable-wise, take those one piece at a time. For the k, well, it's 13 divided by 3. So we're actually going to take 3 and divide it into 13. I'm going to go 4 times with 1 left over. And then for the p's, we'll do the same thing. That's p to the 6 divided by 3. And when we divide 3 into 6, that goes evenly 2 times with nothing left over. Again, these are our outside powers, and whatever we have left over, that's our inside powers. So putting everything back together, we've got this 3 on the outside. We've got k to the 4th on the outside. We've got p squared on the outside. And then on the inside, again, small thing, but make sure we put to the third root there. We've got this 5. We've got 1k and no p's. So that would be the final answer that we're looking for there. Okay, and then the one last little thing that they'll throw at you in section 3 is you're still simplifying, still working, breaking the numbers down, going through everything. But they're going to give it to you in fraction form. And with the fraction form, we'll give you a couple here, just kind of walk into it. They're going to give you something like this. So say we're doing the square root of 4x to the 7th over x. Okay, so you've got a fraction inside the square root, and these are where you don't exactly have perfect square numbers. You kind of sort of do, but maybe not quite so much on these. First thing you want to do is go ahead and simplify what you can on the inside of the fraction. So we're going to simplify the fraction part of it first. Once you've got the fraction on the inside simplified as much as you possibly can, then go back and simplify the radical. So if you have the square root of 4x to the 7th over x, that if you have variables stacked on top of each other, where that's x to the first, all you have to do is just subtract the exponents. So we've got square root of, well, there's nothing to simplify 4 with, so it's just square root of 4. But where you've got x to the 7th over x to the first, you can just subtract those two exponents. Make it x to the 6th. And then once you've done everything on the inside that you can possibly do, now you go ahead and bring in the square root part of it. We have the square root of 4, which would be 2. And then you have the square root of x to the 6th. So that's x to the, when we do x to the 6th, that's 6 divided by 2. In that case, that's an even number, so that comes out to be x to the 3rd. So when they start throwing the fractions at you, they still want you to kind of go through the process of what you're doing. But you've got a fraction, so do everything fraction-wise that you can do first. And then once you've gotten that part that you can do, then you go ahead and kind of bring in the radical. And they'll throw this at you a couple different ways. We'll do a couple more of these just to make sure we've got it. So let's say we're going to do square root of 200c to the 14th. And that's over the square root of 8c to the 6th. Okay, so number-wise, you've got 200 divided by 8. If you check it, actually does go evenly there. Take 200 divided by 8. That should go 25 times. And then if you've got c to the 14th divided by c to the 6th, again, basically you're just subtracting the exponents there. So that would be c to the 8th power. So even in that part where they give you fractions with what you have, you still think about it as two separate problems. So it's still the square root of this number, and then you've got your variables on the end, so you can still separate off from the two problems. And now you've got square root of 25, which is just 5. And because we're doing square root here again, you're taking 8 divided by 2. So that would just be c to the 4th. Okay, and then the one last one that we'll look at. We have 5 squared of 63 over 9. Okay, so if you simplify the fraction, we've got square root of 63 over 9, but the square root's by itself. So fraction-wise, we basically got just the 5 over the 9. Nothing you can do to simplify 5 over 9, so for that part, we've got to take the 63 and break it down. So we'll kind of do that on the side over here. If you take 63 and break it down, you can make it 3 times 21. 21, you can make it 3 times 7. And again, all those are prime numbers. So we take the square root of 63 and break it down. It's 3 times 3 times 7. There's your pair of 3's. So we can take that 3 out, and the 7 will stay on the inside. Okay, so where we've got square root of 63, I'm going to take that out and make it 3 square root of 7. And again, one small thing, that it is 5 times the square root of 63, so if we go back and put the numbers in, it's 5 times 3 times the square root of 7, divided by 9. And then now that you've got 5 times 3 divided by 9, well, with the 3 and the 9, you can divide both of those by 3. So now you've got 5 times 1. On the outside for 5, the square root of 7 stays like it is because it's the only square root there. And then you've got the 3 on the bottom. So that's one of those where there's nothing you can do to simplify the fraction, so you have to go to the radical. And then once you break down the radical, well, now it's back to you've got some parts you could actually simplify. And somebody may be asking, well, could we have taken 5 times 3 and made it 15 square root of 7? Actually multiplied it out. Sure, but now you've got 15 over 9, divide them both by 3, and then you're back to the same answer here. So you could kind of go either way there and get what you were looking for.